Good morning, friends. Once again, welcome you to this lecture, and we have completed the recent topic, that is earth pressure. Different aspect of earth pressure we have completed. First of all, why earth pressure is required, then what are the different types of earth pressure at rest, earth pressure, active earth pressure, passive earth pressure, how to estimate them, then different theories. Basically, I have spent more time on Rankine's theory, where in fact we have the several assumptions. The most important assumption is the wall is vertical, and also there is no friction between the wall and the soil, and those two things, and then additionally there is a level backfill. The backfill also the same line with the top of the wall, and this is the initial thing we have done, and then later on we have introduced inclined backfill also by Rankine, and then earth pressure coefficient little modified, and also we have introduced just Coulomb's theory, what way they are different. Basically, with there any angle of the wall, if the wall is sloped, that can be incorporated. Also, if the friction between the wall and the soil is considered, and any sloping angle in the backfill also can be considered. So, these are the Coulomb's theory is advantageous, and perhaps it gives more closer value to the than value to the actual value, and by estimate it comes little higher, and so since the expressions for this Coulomb's theory, all calculation is little lengthy. So, because of that people sometimes avoid. So, alternatively people what they do, they do Rankine's theory and increase by some amount. So, this is the way to do. So, and then finally, if there is a and while doing all those things, we have considered by and large cohesionless soil, that means granular soil backfill, and also if there is a C5 soil, how this will change, that also we have introduced towards the end. So, with this this earth pressure topic we have completed. Now, I will show the several applications, actually small problem will solve, and then this will be, I hope it will, once again I will repeat wherever required, and then solve the problem. So, first problem reads like this: a smooth unyielding wall of height 2.5 meter retains a dense cohesionless soil having unit weight 18.4 kilonewton per meter cube, an angle of internal friction of 37 degrees with no lateral movement of soil. Draw the lateral earth pressure diagram against the wall and determine the total lateral force acting on the wall. So, this is actually a problem. You have to read the language word proper language, you have to very carefully you have to see. Here it is mentioned the smooth unyielding. So, smooth means it is a Rankine's theory, unyielding means, and there is no movement of soil, that means it is a at rest condition. So, this is the, so we have discussed three different types of earth pressure. So, here from this statement, the unyielding wall, that means there is no movement of wall. So, you have to consider this as a earth pressure at rest condition. So, this is a very simple problem, but still to understand when you will apply or use at rest condition while solving problem. So, language sometime it will mention unyielding wall, sometime also it will be mentioned as a prevented from movement. So, this type of language if is added, then automatically you have to understand that it is a earth pressure at rest condition. So, accordingly you have to solve this problem. So, if you take this problem, this is a very simplest possible problem, and you can see if I do the, suppose the wall is this is 2.5 meter high wall, and it has phi equal to 37 degrees and gamma equal to 18.4. This much information is required, nothing else is required. So, here we know k naught equal to 1 minus sin phi. So, 1 minus sin 37 degrees, that gives you 0.398 or equivalent to 0.4 I can take. So, if I do intensity of vertical stress over depth, so if I do intensity of vertical stress over depth, this will be gamma times h. So, it will be equal to 18.4 multiplied by 2.5. So, this will be your 18 that will be 46, and then if I want to, this is actually vertical stress. Now, if I want to do lateral earth pressure at rest condition, it will be multiplied by k naught. So, if I do this, sorry, this is, it cannot be so it will be 0.4 times of, so this will be 0.4 times of 46, it will be again so this will be sorry, this is I have written also wrongly. This will be 18.4 multiplied by 2.5. So, 46, that is 46, and 46 multiplied by 0.4, that will give you here. So, this will be equal to 46 multiplied by 0.4. So, that will be equal to it will be 18.4. So, ultimately 18.4. So, so this is the this is actually earth pressure at rest condition, and the pressure distribution behind the wall over the depth is something like this. So, maximum is 18.4, and here obviously there is no, so it will be 0, and so there will be total thrust or total thrust will be equal to area of this diagram. So, area will be half multiplied by height is 2.5 multiplied by 18.4. This is the pressure. So, this gives you ultimately 23 kilonewton per meter length, of course, per meter length, because the wall I have shown only 2 dimension, but the wall will be extended perpendicular to the board. So, 3 dimensional. So, I am taking suppose 1 unit width. So, for that it will be 23 kilonewton load will be acting on the wall. So, this is a very straightforward application. We have calculated what is the active coefficient of earth pressure at rest condition, 1 minus sin phi. Then we have got vertical stress, that multiplied by k naught we have got lateral stress, and then we have found out the area to calculate the thrust. and where it will be acting? This will be acting somewhere the thrust finally this will be suppose how much 23, and this will be acting at a height that will be equal to h by 3 equal to 2.5 by 3. So, whatever it meter. Okay, so, with this let me take the second problem. The second problem will be something like this. This problem you can see has sorry. This problem had sorry, this will be next. The second problem is this: for the earth retaining structure shown in figure. So, sorry, this is wrong. Figure only figure number is not required. Oh, sorry. Figure this is not required. Suppose so, this is the figure given as below. So, on this figure, so determine the total active thrust on the wall given h equal to 5 meter, phi 30 degrees, beta 90 degrees, that means this angle, that means vertical wall, h w is 2 meter, gamma is 18 kilometer per hour, q is the surcharge 250 kilometer meter. So, this is a all combination there in this problem, and this is since vertical wall we can use the Rankine's wall Rankine's theory. So, by that let us start Rankine's theory. So, since your phi equal to 30 degrees, your phi equal to 30 degrees. So, you have K A equal to 1 minus sin 30 divided by 1 plus sin 30. So, that gives you 1 by 3, and then you can find out gamma equal to 18. So, suppose I can take a wall somewhere here, I can take a wall somewhere here, and this height is 5 meter, and water table was somewhere here, that is 2 meter, and the total unit weight above and below the water table is can be taken as same. So, unit weight is given 18 kilonewton per meter cube, gamma equal to 18 kilonewton per meter cube, it is given. So, we can do the pressure diagram here. First of all, because of the soil, and you can see up to this that up to water table. So, up to water table the pressure distribution will be something, suppose I will draw the reference from here, take the reference from here. So, up to it will be something like this, and what will be this value? This value will be 1 by 3 multiplied by 18.0 multiplied by so 2 meter is there, so 3. So, it will be ultimately this become 18, this intensity here 18, and now below the water table what will be the value? This will be so you can assume this much pressure already acting here, and because of the soil from here to here additional pressure will come. When I consider soil here to here, they are submerged. So, submerged unit weight will be taken. So, that one diagram may come something like this. So, how to find out this one already 18 there, and what is the value of this? This reference can be taken as 0. So, it will be ultimately your k is the 1 by 3 multiplied by gamma is 18 minus 9.81. This is nothing but gamma submerged. So, multiplied by h equal to 2. So, this gives you the value equal to 5.46. So, this is actually the we have got 3 parts, 1 part, 2 part and 3 part, and this is regarding only the soil. And now, since the water is there, so water also will give a pressure on the wall. So, that water pressure diagram will be something like this, already I have discussed, will be something like this, and this value will be 9.81 multiplied by 2. That means, it will be your 19 point. So, 2 19.82. So, this value will be this one, and then and here actually we have not multiplied by k, mainly because k for water is 1, and then we had a surcharge here, already I have discussed that surcharge. Because of this surcharge, it will have a uniform lateral stress, lateral pressure on the wall throughout the depth, and that the magnitude of uniform pressure is will be equal to, this will be equal to q times K A. So, that will be 250 multiplied by 1 by 3. So, that will be equal to whatever value we will see that. So, these are the things. Now, 4 components we have got, 1 component, 2 component, 3 component, this is 4th, suppose this is 4th and this is suppose 5th. Now, I can find out to find out the total thrust, I can find out the thrust 1, thrust 2, thrust 3, thrust 4, thrust 5 and add all, then I will get the. So, P1 will be half multiplied by multiplied by 18 multiplied by 3, and so this will be equal to something, then your P1 equal to 27 and P2 will be equal to it is 2 multiplied by 18. So, it will be 36. P3 will be equal to half multiplied by 2 multiplied by 5.46. So, that means, it is P3 is 5.46, then P4 will be equal to 250 by 3 multiplied by 5, 416.6, and P5 will be equal to okay. So, this is as per notation I have used. So, this can be used as a this can be as this can be used as P5, this is P5 suppose, and this is P4, this is as I have mentioned. So, P4 will be 19.6. P4 will be half into 2 multiplied by 18 no 9.81 9.81 into multiplied by 2. So, this gives you 19.6. So, 9.80 suppose I have taken. So, 19.6. So, these are the value we have got, and lever arm, suppose this is acting from here, this is suppose y 5, so yeah y 5, and this is actually suppose y 4, and this is suppose y 3, and this is suppose acting here, this is y 2, and this force acting here. So, this distance suppose your y 1. So, your y 1 will be equal to 2 plus 1 by 3 multiplied by 3. So, that is actually ultimately it will be 3. And then y 2 will be equal to half of this 2 by 2, that means 1. Y 3 will be equal to y 3 will be equal to 2 1/3 multiplied by 2, and y 4 y 4 will be equal to again 1/3 multiplied by 2, and y 5 will be equal to 5 by 2. Okay. So, then I can consider the resultant force acting somewhere here, and that is y bar distance. So, y bar multiplied by P p will be equal to P 1 y 1 plus P 2 y 2 plus P 3 y 3 plus P 4 y 4 plus P 5 y 5. So, if I do that, then P 1 is something 27 and y 1 is 3 plus P 2 actually is 36 and y 2 equal to 1 plus P 3 equal to 5.46 multiplied by 5.46, and it is 2 by 3 plus y 4, this is y 4 is actually 19.6 and it is multiplied by 2 by 3 plus P 5 is 416.6 multiplied by this is 5 by 2. So, now if I do this, then I get P p already I have got. P p is equal to P 1 plus P 2 plus P 3 plus P 4 plus P 5, and if I do that, then it gets actually 504.7 kilonewton. So, this one if I put here, then I get y bar equal to 2.328 meter. So, that means what you have to do, you have to draw the earth pressure diagram, and for soil first, then there is a water, then water we have to find out, and then surcharge. So, all how to use them already I have discussed. When there is surcharge, simply multiply by a coefficient of earth pressure, and that will be constant throughout. And effective stress for for finding out earth pressure, you have to first find out the effective stress at any depth and then multiply by active art pressure coefficient. So, that is the thing we have done up to this. Since there is no water table, directly gamma times H times K, and that up to this I have reaching. So, this is constant, and from here actually since it is changing. So, I can take another diagram which will be equal to gamma effective multiplied by H into K A. So, if I do that diagram we are getting. So, these all components are shown here, and P 1 P 2. So, I have divided into 4 parts to easily get calculation. So, 4 parts P 1 P 2 P 3 separately I have done. So, totals P P sorry not P P, this is P A. P A will be nothing but P 1 plus P 2 plus P 3 plus P 4 plus P 5. So, this is P 5, and that gives you 504.7 kilonewton, and then by taking moment, resultant force suppose acting as, suppose this is P A at a y bar distance. So, this moment must be equal to the moment of all forces with respect to this line. So, that I have done. Based on that I have got this y bar equal to 2.328. So, this is one application I have done. So, let me go to the next one. So, this is another problem. You can see this is simple application of you can say simple application of Rankine's theory when there is a slope is there, and as I have mentioned, if there is a vertical face is there like this, and if there is the back slope is there, then how to consider. I have mentioned that you have to extend line like this, and then you have to consider this as a wall height. From here to here, this has to be considered as a wall height, and then your pressure will be acting at 2/3 or 1/3 height from the 1/3 from the base, and it will be parallel to the sloping surface. So, to do that I have taken the same problem twice, and you can see the next slide. Sorry. So, this one the wall is wall was vertical, wall is totally vertical, then your K A was equal to cos I, and then cos I minus under root cos square I minus cos square phi divided by cos I plus under root cos square I minus cos square phi, and if you find out this value comes here I equal to 15 degrees and phi equal to 30 degrees. So, if you find out, you get a value 0.373, and then your active art pressure here will be this wall height was how much 9.1 meter. So, it was this was 9.1 meter. So, half multiplied by 9.1 and multiplied by 9.1 half gamma, and gamma was 17.3. This is the volume, and into multiplied by K A. So, 0.373, and if you do calculate, so this is P A. If you find out the value, this gives you 267.18 kilonewton. Okay, and this will be acting somewhere here, and this height will be 9.1 by 3. But another problem was this is there, and in addition to that, this is also sloped like this, and it is like this. So, what I have to do now? I have to find out this height. So, ultimately geometrically you can find out this distance. So, your ultimate height of the wall become 9.1 plus 0.64. So, this become 9.74 meter, and rest of the things K A everything are same. So, your P A will be equal to half multiplied by 9.74 multiplied by 9.74 multiplied by 17.3 multiplied by 0.373, that is Ka, and that will be equal to gives you 306.08 kilonewton. So, this is the difference. Actually, you can see 267 was there and 306, almost 40 kilonewton change is there, and it will be acting somewhere here parallel to this, and this height will be now 9.74 divided by 3 meter, whatever. So, that means by Rankine's theory, if there is a wall back is sloped like this. So, what you have to do? You have to, from the edge, you have to draw a vertical line to intersect the sloping surface, and then from the top of the, from above the top of the wall, you have to take this additional height. So, this additional height can be calculated geometrically if it is I, and then you can find out from geometry this length, and then if you know this angle, then you can find this and this angle, you can find out this. So, 0.64 height we have got actually, then 9.1 plus 0.64, that 9.74 become the new height, and based on that height your calculation is 306 kilonewton. So, there is almost 40 kilonewton difference by calculation if you take this. So, this also, and when you do the stability analysis, additionally this weight has to be taken, etc., that I will not bring again here, we will discuss later on maybe in several in course. So, with this actually this is the third application. I may do some more in the subsequent places. With this, let me stop for this module. Thank you.